on.
Okay, so last time we talked about horizontal and vertical stretches, and we're going to this time talk about horizontal and vertical shrinks. So it says let f of x equal x plus 2. Remember, f of x is the same thing as y, so if this is unfamiliar, it's just function notation for slope-intercept form, y equals mx plus b. And then it says graph, first of all, g of x equals f of 4x, and then also, second of all, h of x equals 1/4 f of x. And then it wants us to describe the transformation. So from our last lesson, we saw that if it's influencing the 4x, it's influencing the input. The x is being influenced. But if it's outside the parentheses, it's influencing the output, the y. Because remember, the f of x is the same thing as y. We talked about that earlier. So with all that review fresh in our head, let's move forward. I went ahead and graphed the equation. F of x equals x plus 2. I found the m, which is a 1 over 1. I found the b, which is a 2. Started at 2 and went up 1 over 1, up 1 over 1. And there's our first line. But now remember, it wants us to do these changes to it. So let's go ahead and start with that g of x it gave us. And so g of x equals f of 4x. So it wants us to transform it. And last lesson, I kind of hinted to the fact that you can do all this with, and the easiest way to do it all is by making this little chart here. It's really the quickest way to do it. And then from there, you can move your line. So it's easy when the input is what's being influenced, because all you have to do is choose any numbers for your x. I'm going to make the numbers small and easy, so I'm going to choose -1, 0, and a 1. Any numbers for your x on this graph. So I chose, oh, hey, got an emails. Sorry, guys. And so I chose a -1, a 0, and then do a 1 for my x. Okay. And then all you have to do is multiply it by the x by a 4. It's really simple, right? So 4 times a -1 is just -4. 4 times 0 is 0, and 4 times 1 is 4. That's too easy. It can't be that easy. It is. And then just look and see what the y would be when when you multiply the x by a 4. What would the y end up being? What would the output be? If this is the new input, what would the new output be? So when x is a -4, what is the y? Well, it looks like the y goes down 2, right? And then when the x is a 0, what's the y? Oh, that should be the same. Remember, it pivots at that point. And then if x is a 4, start at the origin, go 1, 2, 3, 4. What's the y? 1, 2, 3, 4, 5, 6. The y is a 6. Okay, so you use this here. You multiplied it by 4 to get your new y. But then when you're making your new line, it's like you ignore this. So have you ever been in a situation where somebody maybe used you for something, and then they're like, I don't need you anymore. I used you. I got what I wanted out of you, and I don't need you anymore. That's pretty much what we did. We multiplied the x by 4 to get our new output, and then we're like, 4x, I don't need you anymore. I've moved on. So we're really just going to look at these new points to determine our line. So if x is a -1, y, or f of x, or 4x, would be a -2. So if x is a -1, the new line would be that y is a -2. I just go down 2. Cool. And then if x were 0, y would be 2. Well, that doesn't change, because remember, it's pivoting at this point on the y-axis. And if x were a 1, y would be 6. And there's our answer. That would be the new graph. I lost my 6 here. Let's see. Oh, it's pretty close. Okay. And so remember, this is the pivot point on the y-axis. So it's a horizontal shrinkage because it's shrinking away from this horizontal line. The x-axis is the horizontal width. And think of it like a clock. It helps me to think of it like a clock. If you're going towards the clock, you're stretching towards the x-axis. But if you're going the other way, you're shrinking the sphere from this horizontal axis. And notice both the top part of the line and the bottom part of the line are shrinking away from the x-axis. Look at it. They're both kind of, this is getting further away from the x-axis, and on this side it's getting, on this side it's getting further away from the x-axis as I rotate it like this. So this would be a horizontal shrinkage. Woo, cool. Hopefully you see how these boxes were very helpful. And now we're going to do the same thing. We did a horizontal shrinkage, but we did that because the x was being influenced. The input was being influenced. Now we need to try it with the output. So let's go ahead and give that a shot. And we'll try it with the output. And someone's knocking on my door, so I'm going to have to stop right here and answer my door. So we'll continue this in just a little bit.